Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, good morning, student. How are you today? Yeah, I in a good condition. Thank you. Yeah, I hope you all have a good condition and healthy condition. So, before we start our lesson today, let's start by saying isti'azah and basmalah together. Auzubillahiminasyaitonirrajim. Bismillahirrahmanirrahim. And also don't forget to pray together. Pray begin. Enough. So first of all, for you who doesn't have a signal issue or device issue, please turn on your camera so I can see your handsome and beautiful faces. Okay, thank you. And then I will check your attendance first. So please click the link that I have shared in the chat room. If you have clicked the link, please click the present option in the page. Yeah, please. So I will check it. Okay. It seems like the one person is not present, right? Uh, Anyone knows who? Oh, okay, okay. Do you know why? If you have information. Okay, okay. I'll take a note. Thank you for the information. Okay, so let's move to next session. Uh, okay, student. Actually, I want to ask you, have you had a breakfast this morning? Okay, good. What do you eat? Okay, okay. Yeah, I think it's so delicious. Me, I have eat the bread with cheese. Yeah, yeah. Okay, thank you. So, by the way, talking about the breakfast, do you know how long our body digests the food that we eat? Can you guess? One day? Okay. The others? 3 hours. Okay. Okay, okay. Yeah, okay. Thank you for your opinion. Yeah, actually, our body need a long time to digest our food. Yeah, good question. So how we can digest it so fast? Actually, I didn't finish the answer. Okay, so actually we need a long time to digest our food if our body doesn't have some substance that can make it fast. Yeah, do you know what it is? Okay, so keep the question first because I will tell you the objective learning for today. So first, after this lesson, you are expected to explain what the function of catalyst, and then after watch some video and discussing, you expected to mention at least 5 types of enzyme in digestive system. And then the third, after watching and discussing also, you are expected to structuring how enzyme works. And the last, you are expected to give your opinion or argument about the characteristic and how the enzyme works when discussing. Yeah, actually by this learning objective, you have the answer about the question, but I will not give you. I will not tell you the question quickly. Yeah, because you need to read the textbook first. So I want you to read the textbooks for yeah about 5 minutes. In uh, session 7 at at 101 page until 104. Yeah, please read it first for 5 minutes, okay? Hey, have you finished read the book? So, okay, what the answer of this question? Why we can digest it so fast? Yep, of course, because there is enzyme in our digestive system. But before we learn about enzyme, especially enzyme in our digestive system, we should know about the catalyst. Yeah, if you have read the book, you will find the catalyst. So, what is the catalyst? Uh, Catalyst is a substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical change. So, yeah, actually, the catalyst it's not the end. Not only the enzyme, but the enzyme is one of the catalysts. And yeah, the enzyme is protein that act as a biological catalyst. Especially in our body, there is so many enzyme. And what we'll learn today is about the enzyme in our digestive system. Okay. So what do you think about the enzyme of our digestive system? Yeah, actually, when we when food that we eat enters to our body will absorb some substance that contain in the food that we eat, and to get the substance, uh, our body need to break down the food. To break down the food, we need the enzyme. So when the food needs the enzyme will break down the food and get some substance that we need to our body. And yeah, if there is no enzyme in our body, so when the food enters our body, it will need a long time to break it down. Nah, now uh, what are the enzyme in our digestive system? Is one enzyme used to digest all of the substance of the food, or how? How do the enzyme digest our food? To answer that, let's watch the video first. So I will share the video. Wait. So, is it appear in your screen the video? Okay. How about the sound?
Is
Okay.
it odd to have a favorite?
Let's watch the video.
Is it odd to have a favorite protein? Well, I don't think so. Probably because my favorite protein happens to remind me of one of my favorite childhood games, Pac-Man. If you haven't played Pac-Man before, then chances are we're much older than you. But now you can play it on Google. Just Google Pac-Man. It's a Google Doodle. Anyway, I digress. But see, in Pac-Man, you have this little character. It goes around, finds these pebbles, and the pebbles fit right into it. Well, a lot of illustrations that you will find of enzymes, they happen to look, at least to us, a lot like Pac-Man. I remember P for Pac-Man and P for protein. Most enzymes are proteins. Now, in the game, we mentioned there are these little pebbles that Pac-Man goes after. Well, enzymes have a specifically shaped area called an active site where items can bind. The items are called substrates. It's very specific binding because the active site is specifically shaped for the substrate that binds there. Very specific. So, what happens when a substrate binds an enzyme? Well, usually the substrate is held there with some weak bonds because it's not going to stay there forever. And something called induced fit will happen, which means the active site can change its shape even more to bind that substrate, like an enzyme substrate hug. The enzyme can either build up or break down the substrates that specifically bind to it, and we call the resulting item the product. An enzyme has the ability to really speed up reactions. Reactions that technically could happen on their own, but with the help of enzymes, they can be sped up to make processes effective for life. Let me give you a great real life example. The enzyme lactase. Another really cool thing about enzymes is that they often end in ASE, like lactase. Many sugars, on the other hand, end in OSE, and lactose is an example of a sugar. Lactose is a disaccharide, meaning it contains two sugar molecules bound together. We don't actually digest it so well in that form. It's big. The enzyme lactase has the ability to break lactose down into smaller parts that our body can digest. And this is a lot better option than waiting for a chemical reaction with lactose to happen spontaneously. Now, with the lactase enzyme, lactose can be broken down quickly and digested. Now, there are some people that do not produce enough lactase. They can be what we call lactose intolerant, which means that if they consume foods that have lactose, such as milk, it can make them sick. They can't break the lactose down efficiently without lactase. In that example, one thing to point out, lactase, the enzyme, can break down a lot of lactose, the substrate. The lactase doesn't get used up in the reaction, it's still there. We call enzymes a catalyst because they can be used over and over and over and over in the reaction. By the way, your digestive system uses all kinds of enzymes. You have lipase, and that breaks down lipids, which are fats. You have amylase, which breaks down starch. You have protease, which breaks down proteins. So, as you can see, the digestive system is very involved with enzymes. Another thing to point out is that enzymes don't always work alone. Sometimes they get some help. Some often underappreciated but essential little helpers are called cofactors and coenzymes. They may bind to the substrate or to the active site. They help the enzyme do its job of building up or breaking down substrates into products. Now, you didn't forget our Pac Man analogy yet, right? In the game Pac Man, there are these ghosts. And when they touch the Pac Man, it makes this sound. It's like, no, 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 no. And the Pac Man shape gets all distorted in the process. So, what does this have to do with enzymes? No, there aren't ghosts around, but enzymes do have certain ideal conditions that they like. For example, an enzyme that is in your stomach would have an ideal pH that is very acidic because the environment in your stomach is very acidic. Different enzymes have different ideal pH and temperature ranges. If an environment changes out of an enzyme's ideal pH or temperature range, then something that reminds me a lot of that horrible sound I tried to make can happen. The enzyme becomes denatured. That means its shape becomes distorted. It can no longer bind to its substrate. It can no longer work correctly. It is finished. Well, that's a dramatic end to enzymes. Keep in mind that if you have an interest in this topic, many medical researchers have a large focus on enzymes. Enzymes regulate a lot of the body processes, and many diseases can involve specific enzyme production, or the lack of it. Well, that's it for the Amoeba Sisters, and we remind you to stay curious.
Yeah, okay. Okay, that's the video. So after you watch the video, or anyone want to share what do you get from that video, please? Yes, okay, please. Okay, so yeah, so the enzyme is work specifically very specific. Okay. Uh, what does it mean by specific? Anyone, please? Yes, yes, please. Okay. Oh yeah, the example. Yeah. Okay. Yeah. So for the example, the lactase enzyme work only with the uh, lactose sugar. Okay. Okay. Thank you. Thank you. So actually yeah, I will explain some. I will tell you something about the enzyme, especially about the characteristic. Yeah, so there is some characteristic of the enzyme that we need to know. Yeah, the first is work specifically, like what you are said. Uh, that's right. What your opinion is right because the enzyme works specifically because actually there is more than one enzyme in our body, and every each of enzyme have the pair substrate that can match or can bind with it. So that's why enzyme can work specifically. And also the structure of enzyme, there is some inactive, uh, there is some site, inactive site. Actually, the enzyme have an active site that the shape can match only with one substrate. Yeah, for the example, like you have child. Yeah, for example, the enzyme lactase have the active site that the shape of active site can match only with the sugar lactose. Yeah. So my question is is the enzyme will run out when the enzyme bind the substance or substrate? Okay, okay, yeah. Why why it can happen. Okay, yeah. Okay, so anyone want to explain why the enzyme cannot run out even they have a reaction with substrate? Okay, so because the enzyme is the catalyst. If you remember the definition of catalyst, the catalyst is the substance that can increase the rate chemical reaction without any changes with with the that substance. So that's why after the reaction finish, it can be used again and again and again. That's why the enzyme can be repeated. Okay. And next characteristic is the enzyme can make reversible. Actually, this characteristic have told in the video. Do you know why the enzyme can react reversible? Yeah, okay, yeah, that's right. Because the enzyme actually can break down and also can build up the substrate. Yeah, it's depend what enzyme and what the product that the our body need. Okay, and then the next is characteristic is require in the ideal condition, which are the pH and the temperature. Yeah, yeah. Actually, the enzyme is not run out, but actually the enzyme can be denatured, right? That is stated in the video. The enzyme can be denatured if what? Yeah, if the pH or the temperature changes. Yeah, because the enzyme need some ideal environment in our body. And the last is the enzyme composed of apoenzyme and a cofactor. Yeah, it's the cofactor actually the substance that not protein actually, but it help the enzyme to break down or to build up the substrates to make some product. Yeah, to make easy to understand how the enzyme work. Nah, yeah, uh, like this. Yeah, there is actually this is the enzyme, and there is some active site in the enzyme that only match with a specific substrate, and then after the substrate meet the enzyme that will binds, and after that there is some reaction that can make the substrate change to some product, and then after that the products leave the active site of the enzyme. And see, the enzyme still in their shape, they are not changes, that nor and or and not break also. Okay, and next, actually in our body there are some many enzyme, yeah, especially in our digestive system. In the video there is state only three an example of enzyme. Actually we have at least six enzyme. Yeah, amylase for breaking down starch or carbohydrate into sugar. protease, break down the protein into amino acid, lipase, so breaking down fat into fatty acid, maltase to break down the maltose, lactase to break down the sugar lactose, and the sucrase to break down the sucrose. Yeah, that's all the enzyme that occur in our digestive system. Yeah, that's all for our lesson today about the enzyme in our digestive system. So actually we in the final session in the last session. So anyone want to conclude what we learned today? Or yeah, actually, what do you get from this lesson from today lessons? Okay, please. Okay, good. So the enzyme is catalyst, and the catalyst is the substance that can uh, increase the reaction. Okay, thank you, thank you. The others? Okay, okay. If oh yeah, yeah, please. Okay, so yeah, the example of enzyme in our digestive system, there are amylase, yes, lactose, lactase, protease. Okay, okay. Okay, thank you, student, for your opinion. So maybe I will conclude the lesson for today. Yeah. So actually, the enzyme is, yeah, what you said about the enzyme before. Yeah, you're right. The enzyme is the protein that act as biocatalyst. And what is the catalyst? Catalyst is the substance that can increase the rate chemical reaction. So in our digestive system or in our body, the enzyme can increase the rate of uh, our digestive reaction, digestive chemical reaction. So there are some characteristic of the enzyme. First is work specifically, and then it can be repeated, and then the enzyme is reaction in react reversible, and then uh, need some ideal condition or environment which are the pH and temperature, and then the enzyme composed of apoenzyme and cofactor. Okay, so that's all, student, for our lesson today. And I will tell you for the next meeting, there is will be conduct some experiment about in this lesson about the enzyme. So maybe I will tell you what's the things that you need to prepare after this meeting. Yeah, I will tell the leader next. Okay. So thank you for today, student, and let's close this class with saying Alhamdulillah together. Alhamdulillah. Assalamualaikum warahmatullahi wabarakatuh.